Hi, welcome to your lesson on solving linear inequalities. If you remember from the past, when you have an equal sign, it's called an equality. When you have these symbols, it's called an inequality. So what is inequality? For example, here we have equality versus inequality. This is an equality situation. We have an equal sign. There's an equation. And as you know, you divide by 4, you get one answer. There's only one answer to this equation. That answer is x is 3. X can only be one number, and it is 3. Let's take the same one and write it as an inequality. Now we have a greater than sign here. 4x is greater than 12. Again, the same process is the same, divide by 4, but we end up with this statement. In this case, there is not just one answer. The answer to this inequality is x values that are greater than 3. That means any number greater than 3. So that could be 3.1, 3.2, 3.33335, whatever, any number greater than 3. So actually there are infinite solutions to this inequality because the solution can be anything greater than 3. That's the main difference. All right, inequalities, there are these symbols, this one, this one, this one, and this one. This is a less than, greater than, less than or equal to, and a greater than or equal to. Just so you know, for what we're going to do today, when you solve these and you graph them, when you have one of these, less than but not equal to, we're going to use an open circle. And greater than but not equal to is also going to be open circle. Once you have that little line there, which means equal to, we're going to use a closed circle. And again, with that equal sign there, closed circle. You'll see when we do some examples. All right, so you're going to take some notes soon, but not yet. So for example, here's x equals 2. It is just one solution. Right there on a number line, we'd put that 1 point. Here we have x is less than 2. All right, so now x can be any number less than 2, any number less than 2. So we draw on a number line, we draw this blue line here showing that x can be any of these values. And then we put an open circle over 2 because x is less than 2, but not equal to 2. All right, there's no little line there, it's not equal to. So x cannot be 2, so we leave it as an open circle, but it can be any number less than 2. All right, now we have x is less than or equal to. You can barely see it there, but there it is. There's that little equal sign, less than or equal to 2. So x can be any number less than 2, but it's also equal to 2. So we shade in that dot above 2 saying it can be 2. It can also be any number less than 2. All right, now we have x is greater than 2. So again, now we're looking for numbers greater than 2. So x is greater than 2. It can be any number bigger than 2. But it cannot be 2 because it doesn't have the little equal sign. It cannot be 2, so we leave an open circle. And now x is greater than or equal to, there's a little equal sign, to 2. So again, x can be any number greater than 2, any of these numbers. It can also be 2, so we shade that in. So x can be any of these numbers. That should be a review of things you've seen in the past. Now let's take some notes. So in your notebook, put a title, Solving by Inequalities, and we're going to do some example problems together. Here's the first inequality. Solve this inequality. Start with an easy one. And write the solution in set notation and show on a number line. So 2 skills that we should know for this unit for sure. So there's our inequality. We're going to solve it just as if it was an equation. So we're going to add 7 to both sides first. When we add 7 here, we get 12. Then we're going to divide by 3, and x is less than 4. So let's show this in set notation. If you remember set notation, we put that little curly bracket. It's the set of x values such that x is an element of the real numbers. So x can be any real number. And comma, here we put a condition, x must be less than 4. So it can be any real number, but it cannot be all real numbers. It's just all real numbers that are less than 4. All right, so there's set notation. On a number line, so we draw a number line like we had in the examples before. And on here, you don't have to mark you don't have to mark 0 and everything, but it's nice to have 0 for sure. You don't have to mark -1, -2, 1, 1, 2, 3, 4. You can if you want, but often it's good to just put 0 on there, and then the point that we're referring to, which is x is 4. Again, you could put 1, 2, 3 here if you want, and 5, 6, 7. But this is saying that x is less than 4. So we're going to put open circle because it's not equal to 4, but it's any number less than 4. So I'm going to show that arrow going that way. This shows us that x can be any value less than 4. Any of these numbers x can be, but it cannot be 4 here, and it cannot be numbers greater than 4 either. All right, here's another one. Try this one on your own. Let's see what answer you get, and then let's see the work. So now we have this equation. I'm going to add 7 on both sides to get 9. Then to get rid of this fractional 6, I'm going to multiply both sides by 6. So when you do that, the 6's cancel here, and 6 times 9 is 54. So x must be greater than 54. In set notation, x such that x is a real number, and x is greater than 54. On a number line, I'm going to put 0 on there, 54. In this case, for sure, you wouldn't want to put all the numbers in between 0 and 54. Now we have to show x is greater than 54. So x is not 54 because there's no equal sign here. So I put an open circle, but its number is greater than it. So I'm going to put the arrow this way. X can be any number greater than. So that what that means is x can be 55, 56, 57, 58, and onwards forever. Next one. Try to solve this one. Okay, first step, you could do two ways. You could multiply the 3 through here, so do 12 and then negative 3m, or you could divide by 3 to get rid of it here and divide by 3 here. I did that step. So I divided by 3, canceled that 3, divide this side by 3, turns into a 3. Now I'm left with just 4 minus m. Now you can go two ways, and it's important to talk about why two things can happen. One way is I did plus m on both sides. So if you add m here, it cancels. If you add m here, you're going to have an m. At the same time, I did minus 3, so I moved the 3 over there. So this turned into 1 because I subtracted 3, and the plus m I got to that side, so there's a positive m. So this tells us, this can be rewritten, usually we like to see the variable first. So if I write this and flip it around, put the m on this side, the 1 on that side, I'll have m is less than 1. And that's the same thing we have here, m is less than 1. Now the other way to approach this one would be, right, what if you thought of subtracting 4 first? If you subtract 4 here, it'll cancel that 4. Or if you subtract 4 here, you'll get negative 1. But you're still left with a negative m here. So you need to, I guess, divide both sides by a negative 1 or multiply both sides by negative 1 to just get rid of that negative sign. And there's a rule to remember here. When you multiply or divide by a negative, when you have inequalities, you have to flip the sign, all right? So if this was multiplied by negative to turn it to positive, and this was multiplied by negative, notice the sign has changed direction from this way to this way, and that matches our answer here. So if you're wondering the reason why is there this rule about flipping this sign when you multiply by negative, well, the rule is right here. You can see it, because this one, instead of just multiplying both sides by negative, you could have done plus m, moved the m over there, and plus 1 and move the 1 over there, and you'd end up with this exactly here. All right, so anyway, there's that. Our set notation is this. And on the number line, we have 0, we have 1, and we're looking for values less than 1. So there's 1. Again, there's no equal sign here, and we say x is any value less than 1. Next, try to solve this one. Okay, here we have this inequality. I have a 3x here, 5x here. I'm going to put the x's on one side by subtracting 3x. So I did minus 3x here, minus 3x here. This now is 2x, minus 7. Here's the 9. Now I'm going to add 7 on both sides. So add 7 there. That becomes 16. Now I'm going to divide by 2 to get rid of that 2. So x is greater than or equal to 8. All right, in set notation, x is any real number or an element of the real number set, but x has to be greater than or equal to 8. On the number line, I'll put 0 on there, I'll put 8 on there, and x is greater than or equal to 8. So now close circle, because x can be equal to 8, it can be 8, but it is also any number greater than 8. So that represents all those numbers 9, 10, 11, and onwards that x can be. Next, try this one. If you don't know how to start, I'll give you a hint. You can multiply everything by 2 to get rid of that fraction. So there's that. We're going to multiply every piece by 2, every term. So this will be multiplied by 2, this, and this. When you multiply this by 2, you get 2. When you multiply this by 2, the 2 cancels in the denominator, and we're just left with negative 3x. Multiply this by 2, 2x. And this by 2, negative 8. Now I'm going to add 3x on both sides to get rid of this negative 3x and to get the x's on one side. So here I have just 2 left, because when I add 3x, that's gone. Add 3x to that, we get 5x, and then minus 8. Now I'm going to add 8 over there. So 10 is less than or equal to 5x. Now I'm going to divide by 5 on both sides, and 2 is less than or equal to x. There's a set notation. When set notation, notice I flipped this around. Again, the variable is nice to have the variable on that side, so I just moved them both like that and switched the sign like that. Now, number line, 0, 2, and x is greater than or equal to 2, so it's equal to 2. So again, we put a closed circle because it's equal to 2, and it's any value greater than 2 also, so we put an arrow this way showing us it can be any value greater. All right, try this one. This one's a little tougher, but again, we see a fraction. We can multiply by 3 first to cancel away this 3, but then we have to multiply all this by 3 as well. Okay, notice when I multiplied by 3, I left a negative sign. It's important. That negative sign has to remain there. So if I put a times 3 here, the 3's would cancel, but this negative and all this would remain like this. On this side, when you multiply by 3, this turns into 15, and this turns into 6. Now I'm going to distribute this negative through this parenthesis here. So both of these will turn negative. There they are, both negative. This side remains the same. Now I'm going to add 2x to get rid of this negative 2x and add it to this side as well. In the same step, I'm going to subtract 6 on this side and get negative 7 here. So again, negative 6 from there, negative 7, and then 2x added to there. Now I'm going to divide by 17, and that as a decimal is negative 0.412. All right, there's our set, there's our number line, there's the negative number, 0, and we're looking for x values less than that negative number. So open circle, because it's not equal to, and left arrow like that, showing all these negative numbers that way. Great. Hey, let's look at this one. All right. I have an I and an X in there. Let's just see what happens. This one, I'm going to do, actually try it. Solve for I. See what you get. All right, let's take a look. So first, multiply this through here. 3 times 3x, and 3 times that is negative 21. U. Now, notice I have 9x on both sides. So if I subtract 9x from both sides, then 9x is going to disappear. It's gone. Now I have negative 7i is greater than negative 21u. Divide by negative 7 on both sides. Oh, I guess they did negative here first. So get rid of the negative on both sides. Notice the sign switched because of the, dividing by negative number. And now divide by 7, and we're left with this. Oh, we have I love you. That's awesome. All right, great. I hope you got that answer when you made your choices. Now, the last thing you gotta do is try these 3. So in your notebook, 3 more problems, and you're gonna enter your answers, all 3 at one time. Do your best. These are not so bad. I think one of them maybe is a decimal. The other 2 work out evenly. Let's see how you do. So check your work. Oh, it turns out 2 of them are decimals, this one and this one. Check your work, see if you can find out where it went wrong, if you can get something to work out. And good luck. There's no assignment that follows this, but if you need to, look back on this video and make sure you understand all these problems, because this is all the practice we're going to do with this skill. You can do it.